clients things that would suggest that these systems are going outbound to the internet. So I'm going to try to wrap it up, make some summary points about the SCADA vulnerabilities, and then we'll jump into smart grid stuff, because that's pretty interesting too. The points we're trying to make here is that you don't really need a SCADA 0-day. They are starting to creep out into the public, and we're starting to become aware of them, but we don't even need them. There's a lot of vulnerabilities out there that already are in the infrastructure. And we're hoping that the asset owners of these systems will do a more diligent approach to perform assessments of these systems, root out their vulnerabilities, patch their systems more frequently, so that this time between when a vulnerability goes live and when it's discovered can be shortened down to hopefully like a month or so, you would hope. But it's almost at a year right now. Also, this DMZ network between the corporate environment and the SCADA environment is the one that's most prone to vulnerabilities, because it's kind of this no man's land, no one owns it, and then you have this scenario whereby it's also connected to everything. So that's another area we kind of want to shine a light on and say, you know, someone needs to draw a line in the sand and say, okay, corporate IT security, you own it up until the SCADA firewall, or SCADA operations, you guys are going to have to manage these systems that are in the SCADA DMZ. And as we found that you know, a lot of these vulnerabilities were run on Microsoft systems, that's where we are today. And we're hoping that we can take a more aggressive approach in managing the security of Windows systems, especially given the criticality of the types of applications and what those applications are doing. And again, down at the bottom, almost every assessment uncovered unnecessary software installed, whether that was on purpose or whether it was software installed by something else, or by a bot or by an agent. So I'll ask the question again that we started with. You still think we're doing a good job? You guys still think we're good? We're Jake. We got a great critical infrastructure going here. I still think that there's a lot of work to be done. But wait, we have NERC CIP to save the day. We have regulations coming out that's going to force the power companies to install security and manage their systems. Well, NERC CIP isn't quite where it needs to be as well, and we're finding that a lot of power companies are wiggling around the definition of what is a cyber asset, what is a critical cyber asset, and they're trying to bend around the regulations to try to reduce their audit footprint. So, and again, oftentimes controls are often bypassed. Now this is really funny. This is another picture I took with my iPhone. This was actually the bathroom facilities at a restaurant that was on the docks where boats would come in and out. And this was actually a women's bathroom facility. So they showed the little shower, which you didn't see in the picture, was like the little women's sign above it. And so they said, okay, well, you know, that we want to make sure that the ladies are secure and the fact that they're going into this bathroom facility and they can take the showers. And so they put a little combo lock on it. And then I guess after so many times of asking for the code, they finally just pasted the code on top of the combo lock. So it defeats the purpose of even having it. So we find that all the time in the SCADA world as well. Someone installs a firewall and they think, oh great, I have a SCADA firewall. And then they do any-to-any connections. And they do like, well, anybody who wants Pi data can write on in it, port 5450. Come in and open up your process books, get real-time data. It doesn't matter, it's port 5450. It's not like a known vulnerability port, so go ahead in, you know. And so we find it all the time. So are we collectively feeling better now? What we have found is that the NERC CIP standards at least forces the hand of the electric utilities to implement a common baseline set of controls, right? So it's been a good thing. I can tell you that we did a disclosure of the vulnerabilities to a panel of execs at a utility company back in 2003. And this was where their CIO, CFO was all present in the room, and we went through the vulnerability assessment report. And there was over 55 vulnerabilities. And the CFO turned to the CIO and said, what is the worst thing that can happen to me if we do not fix any of these vulnerabilities? And the CIO was like, well, you know, we have a lot of exposure here. Someone could, you know, remotely manipulate and disconnect power. And she said, no. What is our financial risk? Like, what can we actually lose if we don't fix any of these? Are we going to be fined? Are we going to be sued? Are we going to have any types of fees from any regulatory agent? And this back in 2003, there was no NERC SIP. Governing security for the electric grid. And the CIO said, no, there's no financial risk. And so the CFO said, well, don't fix anything. You're not getting any budget. You can fix these based on the staff you have and based on the money you have, but you're not getting any money to fix these. So, and that was 2003. what we found today, 2010, is a much different tune, okay? Because NERC CIP has, with the NERC CIP regulations, FERC has the right to instill fines that are up to $1 million per day per occurrence. So those types of financial hit, if they are not found in non-compliance to these security standards, is a wake-up call. So now at least what we found is that the utility sector actually finally has budget and has money to be able to start doing things that they knew they should all along. And most of the NERC CIP standards are logical. They make sense. It's common sense, like have access controls at every digital perimeter going into SCADA. You should log every action done. These things are common sense. You would think people would be doing this already, but it took a government agency like FERC and the NERC Oversight Committee to actually force the utilities to do these things that you would think is common sense. So, but then at the end, even if everyone is playing fair, everyone is doing what they should with NERC CIP, everybody's in compliance, and if we're in a perfect world, all of a sudden, let's now insert some shiny new nifty smart grid gear. So now it's like, oh no, now we got to go back to the drawing board again, because now we just got to the point where we can say that SCADA can be secured. We have a common framework to how to secure SCADA. Now we throw this new animal in the mix, the smart grid, that doesn't have common security standards and proprietary protocols and all of the same things that we dealt with SCADA. So now here's a couple thoughts about smart grid technology. What we found is that automated metering infrastructure, automated metering reading systems have similar vulnerabilities to SCADA systems. So, history is going to repeat itself. The assessments that we're doing on smart grid technology are turning out the same results of the assessments we do on SCADA technology. The same old threats, but now we have different impacts of those threats. So as you look at this, we have the same problem, a perimeter issue. We're remotely collecting all of this information on what power is being consumed, and we're having to push it out and share it with all these different entities. Well, where is the perimeter? How do we harden this system? That's been a big issue with the systems that we looked at. When you actually look at the back-end server applications that are actually collecting all of the data, the consumption data from the homes and businesses, those web applications, database applications, were ported over from older applications that were written in C. They were not even using more modern frameworks for coding practices. And it's like the smart grid companies are taking packages that they know work, and they're porting it over as fast as they can to work with their technology, but they're not actually changing the internal code of the systems. They're not building these systems from scratch. And then if you peel across the next layer, there's too much trust in the protocol. A lot of times the vendors will say, hey, we use Zigbee. And so we have 128-bit encryption, and we follow the Zigbee Alliance, so you should trust us. We're good. And when you start peeling back the layer, and there's going to be other talks about smart meters and the problems in smart meters throughout today and tomorrow, you'll find is you can't just put all your trust in the protocol, because even the Zigbee protocol itself has problems in the way it does encryption. So it's kind of like we're going to go over the same problems and repeat history again. And again, the end devices themselves, the meter devices themselves have the same problems as PLCs and RTUs. If you scan them too fast, they reboot. If you send them malformed packets, they tend to crash. Okay, so now we got the same problem as a SCADA system. We have end devices that have vulnerable stacks. We have protocols that aren't really secure the way they need to be. We have back-end servers and applications that were older frameworks that have been kind of dusted off and resold into the smart grid field. And then we have weak perimeters. So we're kind of like going to go back to the same problem again we have with SCADA. So that's why I talk about deja vu. Now, a lot of times these systems are being rolled out to operate for 20 years without requiring a system upgrade. And that's kind of a fallacy. I mean, I don't think you can ever roll out something nowadays for 20 years and not require it to be updated. So you combine that with the patching and firmware problems, and you get a situation where now you can remotely upgrade the firmware over the air to thousands of devices. Now that's a really sticky situation. Here's some quotes by other security professionals. These guys are both here at the conference, and so they allowed me to put these quotes here, but all it would take is to actually start a firmware download and stop it, or download the wrong firmware, or patch them in a wrong way, and all of a sudden you've got thousands of devices that reboot in an unconfigured manner. So now you have to roll a truck out to 50,000 homes with a serial cable, connect it to the back of the meter, re-flash it, reprogram it to get it to come back up, right? We've actually experienced that. I have some screenshots of what, and actually some code that we used to crash the meters. And it's just a basic ping command. So we have old threats, new impacts. We can read data off these smart grid systems. So data enumeration. What about being able to read if your power consumption, the thing I'm worried about is I don't want anyone else to know what my power usage is, because everybody has their own unique load profiles. When you wake up in the morning, you turn on certain appliances are used throughout the day, you go to work, you come back home, you do other things, right? It builds a signature. If you're actually reading and capturing traffic off these power meters, you can actually determine a load profile. Now, what happens when you go on vacation? I know what I do. I turn off my AC. I live in Houston, Texas. I don't want to have a big, huge power bill. So I turn off my AC, I turn off all my lights, I lock my doors, and I walk out. So if someone was monitoring my power usage, they could know immediately when I went on vacation, and they can target me. They could actually break into my home and know I'm not there, right? So what happens if you were able to read an entire neighborhood and then look at analysis and algorithm that says, okay, when the load profiles change to this, now give me the address and location of all these smart meters, and then throw that on top of a Google Maps. Now it's kind of like, it's like a home invasion's best dream, to actually know exactly when people are going on vacation based on the amount of power they use. So I think data enumeration and privacy is pretty important. Being able to know what systems are connected to this network is pretty important. Knowing what services are exposed, if these embedded smart meters have embedded web pages or offer FTP or Telnet types of services, that's kind of important. Being able to change the data on the fly, steal accounts and passwords, we've done all these things. Capturing traffic. This is the same old stuff you saw before, okay? This is not anything new. Man-in-the-middle attacks still work with smart grid data. And actually changing data on the fly. Just simply moving the decimal point over so that, the last 24 hours, instead of using 250 kilowatts, I use 25 kilowatts, right? Starting to reduce your power. This is where it gets into the concept of electricity for free, right? So how many of you guys have modded your Xbox? How many of you guys jailbroke your iPhone? Don't worry, I'm not taking pictures of the audience. I think the next step is going to be modding your electric meter. I mean, if someone came up with a way to mod the electric meter to run foreign code on it and make it reboot, and then allow you to tweak all the little sensitivities and the way it monitors the energy, you can slowly scoot back the ratios, so that to the point where you can actually be using electricity at like a third of the monitored rate, right? So these are things to keep in mind. But sometimes it's not even that hard. I mean, this is basically administrator writing the clear, not even encrypted. Bricking systems aren't really that hard, to where if you slam with different types of traffic, it comes back with bad system configuration, and you can't even ping it anymore. You have to use a serial cable to then reconfigure it. And just a simple ping attack. Okay, we were just basically pinging these devices and ramping up the byte size of the payload to the point where it just crashed. It rebooted, and then when it came back, it wouldn't actually talk to us anymore. We actually had to hook up a serial cable to it, reprogram it again, and then it came back up with an IP address, and I can communicate it again. Okay, so this is just basic ping commands. What about denial of access? Some of these devices have embedded passwords in them that you can actually change over the wire by actually sending out a command and changing the password. So we wrote a little piece of code and used Metasploit to basically first detect if that device used the password change part of the protocol, and then we sent the next swing out to all of the controllers and changed the passwords. Now, the thing that was interesting is that the password protected application is automatically downloaded on each switching on-off cycle. It cannot be undone if you forget the password. You have to send the device off for repair. Okay, so imagine doing this thousands of times, and then all those devices have to be sent back to the factory because there's no backup password. And so if you don't know the password, you have to send it back to the factory, right? So are you thirsty for more? The thing we want to talk about is SCADA security training. So what we found is that it's missing. We have a lot of SCADA guys that work in plants and control these things, but they don't know a lot about cybersecurity. And we have a lot of IT professionals that know cybersecurity, but don't really know a lot about SCADA. So we developed a 5-day training course whereby you build a SCADA system yourself. You build the little controls, you turn